Assalamu alaikum. We're going to start looking at the remaining organic reactions. We've already done one so far in this course, which is esterification, right? So that's the production of an ester by reacting a carboxylic acid and an alcohol together. There are 6. I know it says 5, but I've included the 6th one here. So what I'm going to do is just erase that. Your textbook says 5, but I included a 6 because really it is an important organic reaction. There are 6 main types of organic reactions, and we have already done this one. Okay, you've also done this one in grades 10 and 11, right? We know that it's any organic compound burnt with oxygen gives you carbon dioxide and water. These other 4 are what are quite unfamiliar to us. So today, in this video, we're going to cover addition reactions and substitution reactions. So what the addition reaction is, it's when there's a breaking of a bond between carbons. So you would go from, let's say, an unsaturated hydrocarbon, which unsaturated means alkene or alkyne. So it's just a synonym. So you'd go from an alkene or an alkyne to an alkane. You see, there would be at least one double bond there, and that double bond is broken. Now, there are 3 main means to do this, okay, with regards to an addition reaction. So we give those subclasses separate names, but they're all classified under the umbrella of addition reactions because all of these will essentially do the same thing, and that is to break one of the bonds, one of the double or triple bonds of the alkenes or alkynes. So the first one is hydrogenation, and it is kind of what it sounds like. The root word is hydrogen. So let's say we take an alkene here. And so this would be called, if we were to name it, 1, 2, 3, this would be propene. We don't need to write number 1 because no matter what carbon I would put the double bond on, it would be number 1 anyway. So propene plus H2. Okay, and so what you're really doing here, the addition is, when it comes to hydrogenation, is adding, elemental hydrogen gas. Okay, and so this is what happens. When we write H2, what we really mean is H to H. And of course, this often needs like a catalyst of some sort. It can be heat, but in other cases, it's just either palladium catalyst or, there's many catalysts that can be used. So each hydrogen, with the presence of heat in a catalyst, is going to attack and bond itself to each end of the double bond. And when that happens, what you end up with is that double bond broken and it being replaced by hydrogens. Let's do another example. So in this example, we have again an alkene, right? It's a unsaturated compound. And we're going to start naming. We can go either from the left to the right, but this is 1, 2, 3, 4. And because the double bond can be on 2 different carbons here, we have to specify where that is. So we're going to write but-2-ene and then plus hydrogen. So just like in our previous example, hydrogen, right, is really H bonded to H. It's H2. And each hydrogen is going to attack each end of the double bond. And what you end up with when that happens, okay, and I'll just erase this here, is you end up with butane that is now accompanied with hydrogens as opposed to the double bond that it used to have. And so you can see that the double bond is broken. Now, let's look at our second subclass, halogenation. The root word is halogens. And so what we're going to do, kind of like what we were doing with our hydrogens, you're going to add a halogen. And a halogen is the second last group in the periodic table. It's the one right before the noble gases. So add halogens to break your double or triple bond. And so we'll show you how this works with an example here. So let's say I go like this, and in this example, we're going to give you let's give you a simple one, an ethene plus chlorine gas, right? Well, chlorine, just like in our previous examples, is Cl2, which is Cl bonded to Cl. And so each Cl is going to attack each end of the double bond. And so when that happens, we end up with this, and the double bond is replaced with a Cl on each side. And so it goes from ethene to 1,2-dichloro, ethane. And so this is under the umbrella of addition reactions because, like our hydrogenation beforehand, a double bond is broken and it turns into a haloalkane, okay, which means an alkane with halogens on it, like our ethane over here, right? Let's do another example. Now, in this example, I have an alkyne. You can see the triple bond over here. And so, like our previous examples, we're going to use our halogen, which is I2 or I bonded to I, to break the double bonds, or the triple bonds. But the thing is, we're going to need more than one because each halogen can attack this double bond, or this extra bond, but then, because there's a triple bond, this one is still left over. So what we're going to need is we're going to need 2 moles of this. Because there'll be I to I, which attacks these double bonds, and then a second one, and we'll do this one in a different color, a second I to I to attack these ones. And so finally, once this reaction is done, we would have 4 I's attached to our newly formed alkane. And they're going to be attached right where the double bonds used to be, or the triple bonds. Okay, so the question is, how do I know when to do, when do I add 2 moles? If it's an alkyne, add 2 moles so that you can break all the bonds. Because in the end, we want all the bonds to be broken except for the single bonds between the carbons. But if it's just an alkene, then no need to add an extra mole. Just do the regular, regular halogenation reaction. Now, when we look at the third and final subclass of an addition reaction, just like the other two, the hint of what occurs in it is in the name. So hydrolysis, when we say the word hydro, you think of water, right? So in this case, you're still going to break double and triple bonds between carbons, but we're going to do that with the addition of H2O. Okay, and of course to an alkene or alkyne. So let's look at an example here. Let's say we have this. Okay, and we add water. Okay, now, in previous chemistry classes, I told you guys that you can rewrite water as HOH to help simplify the balancing. I would say rewrite it in this case so that the reaction will itself make sense. Each component of the water will attack an end of the double bond. The H is going to attack this end, and the OH is going to attack this end. And what we end up getting is hydrocarbon where the alkene is broken, but on each end we got an H over here and an OH over here. And this now becomes an alcohol. I'm going to give you another example to show you how this works, and then we're going to write a general rule. So example 2, let's say I were to do okay, this time we have a but-1-ene. So, just like we did in our previous example, we're going to split our H into H2O and H and OH. And each component here is going to attack an end of the double bond. And so your H attacks the first end, and then this one will attack this end. And what we end up getting here is an organic compound, once again, with its double bond broken, but there's a hydrogen on this end and an OH on this end. And this is, again, an alcohol. So we're going to write the general trend for hydrolysis is that the addition of H2O to an alkene creates an alcohol. I strongly encourage you guys to retry these examples yourself first, and then try the examples on the worksheet as follows. Assalamu alaikum.